Welcome to the world of Retrieval Augmented Generation. This cutting-edge AI paradigm merges the best of both information retrieval and natural language generation to create systems that are not only intelligent but also contextually aware. RAG allows AI to fetch relevant information from a vast corpus of data and use it to generate coherent and contextually accurate responses. This is akin to having a knowledgeable assistant that not only understands your queries, but can also pull in relevant information from an expansive library to provide well-informed answers. In essence, RAG enhances the capabilities of traditional generative models by grounding their outputs in real-world data retrieved on the fly. This not only improves the accuracy and relevance of the generated content, but also makes the AI system more robust and versatile. Traditional natural language generation systems rely solely on pre-existing knowledge encoded during their training phase. This can lead to outdated or irrelevant responses, especially when dealing with dynamic or niche topics. Retrieval Augmented Generation, on the other hand, augments these generative models with real-time information retrieval, ensuring that responses are not only accurate but also up-to-date and contextually relevant. This makes RAG an indispensable tool for creating more reliable and intelligent AI systems. You may wonder how this information retrieval works. At its core, information retrieval involves three main components: the user query, the retrieval of documents from a large corpus, and the ranking of these documents based on their relevance to the query. First, we have the user query, which is typically a string of text that the user inputs to express their information need. Next, the retrieval component involves searching through an indexed corpus of documents to find matches. This is where various algorithms and techniques come into play, such as vector space models and dense retrieval methods like dual encoder models. Finally, the ranking component sorts the retrieved documents based on their relevance to the query. Traditional information retrieval systems use algorithms like PageRank, while modern systems often employ machine learning techniques to enhance ranking accuracy. Now, let's understand what is natural language generation, or NLG. NLG is a subfield of artificial intelligence that focuses on generating human-like text based on input data. It's used in applications ranging from chatbots and virtual assistants to automated content creation and summarization. The NLG process typically involves three stages: content determination, text planning, and surface realization. Content determination decides what information needs to be conveyed. Text planning structures this information into a coherent sequence, and surface realization converts the structured information into fluent, natural language text. Early NLG systems were rule-based, relying on predefined templates and grammar rules. These systems were limited in flexibility and adaptability. The advent of neural networks and deep learning revolutionized NLG, giving rise to powerful models like GPT. These models can generate highly coherent and contextually relevant text by learning from vast amounts of data. The birth of RAG. Combining information retrieval and natural language generation leads us to Retrieval Augmented Generation, or RAG. RAG leverages the strengths of both information retrieval and natural language generation to create systems that can retrieve relevant information in real time and generate informed responses based on that information. In a typical RAG system, the process begins with a user query. The information retrieval component retrieves relevant documents or snippets from a large corpus. These retrieved pieces of information are then fed into the natural language generation component, which generates a coherent and contextually accurate response by integrating the retrieved data with its generative capabilities. Unlike traditional natural language generation systems, which rely solely on their pre-trained knowledge, RAG systems can dynamically fetch and incorporate real-time information, making their responses more accurate, up-to-date, and contextually relevant. This makes RAG particularly useful in domains where information is constantly changing or when dealing with niche topics that may not be well represented in the training data of standalone generative models. RAG offers several key advantages over traditional natural language generation and information retrieval systems. First, improved accuracy and relevance. By integrating real-time information retrieval, RAG systems can generate responses that are grounded in the latest available data, ensuring greater accuracy and relevance. Second, enhanced contextual understanding. RAG systems can leverage the retrieved information to provide more nuanced and contextually aware responses, improving the overall user experience. Third, Flexibility and adaptability. RAG systems can easily adapt to different domains and knowledge bases, making them suitable for a wide range of applications, from customer support to content generation and beyond. Lastly, scalability. With advances in cloud computing and distributed systems, RAG models can be scaled to handle large volumes of queries and data, making them suitable for deployment in high-traffic environments. Now, let's explore the architecture of Retrieval Augmented Generation. The high-level architecture of a RAG system consists of four main components: the user query, the retriever, the generator, and the integrator. User query is the input provided by the user, typically in the form of a natural language question or request. The retriever component is responsible for fetching relevant information from a large dataset. It typically involves three key steps. The first step is indexing. It involves creating an index of the documents in the corpus to facilitate fast and efficient retrieval. Indexing techniques can vary from simple keyword-based approaches to more advanced vector-based methods using dense representations. The second step is searching. Once the index is created, the retriever uses it to search for documents that match the user query. This can involve techniques like TF-IDF, BM25, or more advanced methods like dense passage retrieval, which uses deep learning to understand the semantic meaning of the query and documents. The third step is ranking. After retrieving potential documents, the system ranks them based on their relevance to the query. This ensures that the most relevant information is prioritized for the next stage. The generator component is responsible for creating a coherent response based on the retrieved information and the user query. This process involves three main steps. First is input processing. The retrieved information and user query are processed and encoded into a format suitable for the generative model. This often involves converting text into embeddings using pre-trained language models. Second is text generation. The generative model, such as GPT-3, uses the processed inputs to generate a response. These models are trained on vast amounts of text data to produce human-like language. And third is output refinement. The generated response is refined to ensure coherence, relevance, and fluency. This may involve additional processing steps like post-editing or re-ranking based on context. Finally, the fourth component is the integrator. The integrator component combines the outputs of the retriever and generator to form the final response. It involves three key steps: combining, validating, and finalizing. First, the integrator merges the retrieved information with the generated response, ensuring that the final output leverages the strengths of both components. Then the combined response is validated to ensure accuracy and relevance. This may involve checking factual consistency and coherence. And finally, the validated response is finalized and formatted for presentation to the user. This ensures that the output is clear, concise, and ready for consumption. With a detailed understanding of the individual components, let me brief the complete workflow of a RAG system. When user submits a query to a system, the retriever searches the corpus and retrieves documents relevant to the user query. Then the integrator combines the retrieved information with the user query. Then the generator produces a coherent response based on the integrated inputs. Once the response is produced, the integrator validates and finalizes the response. And finally, the system presents the final response to the user. This workflow ensures that the response generated by the RAG system is not only accurate and relevant, but also contextually rich and up-to-date, leveraging real-time information retrieval and advanced language generation capabilities. Congrats! Now you have an understanding of what is Retrieval Augmented Generation, its fundamental concepts, information retrieval and natural language generation, and the architecture of a RAG. So, stay tuned for the next video on the algorithms and techniques used in a RAG and the building blocks of the RAG systems. If you have any questions, feel free to ask in the comments down below. Thank you for watching. Please like and share the video, and subscribe for more such amazing content.